All right, we've looked at our very first distribution functions, our very first cumulative distribution functions. We will be using these cumulative distribution functions quite a bit as marketers for calculating different aspects of our measurements. For instance, if you want to know the probability of obtaining a measurement at or below a given score, that is simply the cumulative distribution function. So at or below is simply the cumulative distribution function. But when we look for the probability of obtaining a measurement at or above a given score, we'll take 1 minus the cumulative distribution function at that score. This is for continuous distribution functions, like the normal distribution. We're looking for the probability of attaining a measurement between 2 points. So this is like you have an interval. You're trying to find the probability of having a measurement between my lower limit and my upper limit. Looking between these two scores, we're going to take the difference of the cumulative distribution function at the upper limit here and of the interval and the distribution function at the lower limit there. So basically, you look at the upper limit and you subtract off that at the lower limit. Why will this work? Well, the cumulative distribution function at the upper limit is the full probability of being up to that point. The cumulative distribution function at the lower limit is the probability of being up to the lower limit of the interval of interest. And so by taking the full distribution function, for instance, I'll draw it here. There we have it. Suppose that this is my upper limit and this is my lower limit. So there's my upper. Now basically, I'm taking all of this area here, and then I'm subtracting off this area here because it's not relevant. And I'm left with the probability of it being finding a score between these two measurements. For discrete distributions, the probability of obtaining a measurement at or below a given point is found simply by taking the probability from the lowest score up to the interval of interest, up to the score of interest. When we're looking at the probability of obtaining a measurement at or above, we'll literally do the same thing, but in reverse. So to find the probability of a measurement at or above a given score, it is found by taking the cumulative probability starting from the highest measurement of the interval down to the given score. So the highest measurement interval down to the given score of interest. When you're looking at it between two scores, you simply accumulate the probability between the scores of interest. Again, let's do this in Excel. So here's our female shoe size with our cumulative distribution function. There's our cumulative response probability. So here's the probability of finding a size 7 or below. I'm going to move this over a little bit. Suppose I wanted to find the probability of obtaining a shoe size at or above a given score. So slightly different measurement. Make this look pretty. There we go. Here, I took the one above and went up. Here, I'm going to go the absolute opposite direction. So 0.2% of people say a size 12. I'm looking at the probability of obtaining a shoe size at or above a given score. So this one would be 0% plus what was below it. I can just copy and paste that all the way up. So the probability of obtaining a shoe size at or above a given score goes in reverse. 100% of the people have a size 4 or higher, but only 2.6% of them have a size 4 specific. we will need to use this as marketers. Suppose I want to know the probability of being between a size 7 and 8. I would literally just add these two numbers up. Here, those two response probabilities. You can see down here in Excel that answer is 54% of the population have a size 7 or 8. With this knowledge, you're now prepared to do the exercises Kale, in the back of the book, men's shoes, and a firm performance as well. Here, for a continuous distribution function, suppose I want to know the probability of being up to a given score. Like, for instance, my upper limit, I'm going to move this here, move it here, I'm going to make this my lower limit. My upper limit on some interval is a, I don't know, 65. I want to know the probability of being up to 65. I literally just take the norm dist at this point, using the mean, median, the standard deviation, true. So I find 99% of the people have a size, it looks like 100%. 99% of the time I will get a response below 65. So this is below 65. Now how about above 65? In that case, I will literally take equals 1 minus the norm distribution of this point given my same mean, comma, standard deviation, true. So the probability of finding it above 65 is 0.1%. The probability of finding it below 65 is 99%. Let's try another number like 42. You see the probability of finding the score below 42 is 5.5%. So above is 94.5. And the entire probability is always going to add up to 100% because that's the probability of finding it somewhere on the planet. Notice here they add up to 100%. Here they did not. Why not? Because here we have a discrete distribution function. And with the discrete, if I just did 1 minus, I would constantly be leaving out the current score. And the question asked here is, what's the probability of obtaining a shoe size at or above a given score? If the question was just above, I could have used 1 minus. But the question was at or above. So be very clear, pay close attention to specifically what it is you're trying to measure. Now, what if we want to find the probability of being between 2 points? So suppose my upper limit and my lower limit. And I have some interval. And let's say the interval is between 55 and 45. I want to find the probability of finding a measurement between 45 and 55. To do this, I am literally going to take the difference of the normal distribution of the cumulative distribution function at the upper limit and the lower limit. So I'm going to use the norm dist, that'll give us the cumulative distribution function, at our upper limit, giving our mean, our standard deviation, our true, because we do want cumulative, minus the norm dist at our lower limit, given the same mean, standard deviation, again true. We find that about 65%, 68% of the time, you get a response between 45 and 55. Where did that 68% come from? Or why does it sound familiar? Because between 45 and 55 is 1 standard deviation. Remember, that did give us 68%. With this knowledge, you should be prepared to do the exercises on the weighty challenge for men, the weighty challenge for women. It'll also help you do some of the work regarding the firm performance exercise and the graduates versus non-graduate exercises at the end of Chapter 5.